you a brief presentation of some of the work that we've been doing on providing execution environments. So compute sessions for running executable documents. And I'm going to run through a bit of a demo and just describe how we're using that to bring the vision of having executable journal articles and other interfaces available. So I'll just start my screen share here and show you a presentation. So we've been working on a couple of new projects, and the one that I'm going to talk about today to begin with is Executa. So Executa is a relatively new project that provides a set of specifications for the how of executable documents. You might be familiar with our schema repository, which provides JSON schema for the nodes in an executable document, describing things like everything from code chunks through to paragraphs and emphasized text and tables and so forth. So while schema describes the what and the shape of executable documents, Executa is a set of specifications around the how of those documents. So how to execute them and how different executors in different languages communicate with each other. So we've always had this aim of having multi-language or polyglot executable documents where you could have code chunks and expressions in different languages. And so we need to have a way for those different executors to be able to talk to each other. So Executa defines the way that those execution engines talk to each other, and it sets up a protocol for communication over a number of different transport layers. So many other approaches to this have chosen one layer for transport, one transport layer, so it might be something like HTTP or 0MQ. We've gone for a protocol which can be sent over different transport layers, including HTTP and WebSockets, but also things like pipes, which allow for a lot more security and are a lot faster. Sparkla is the other project that we've been working on. It's a compute session manager built on top of Executa. So while Executa provides the base API, Sparkla implements those API interfaces and provides a way of launching sessions that are isolated and reproducible. And it does that currently using two backends. One is Docker, which many people will be familiar with as a container framework, but the other one is a relatively new project from Amazon called Firecracker. I'll go into those a little bit more now. So with Docker, you'll be familiar with how a Docker sets up a container as an isolated environment. And this diagram shows how we're applying Executa when we're running Docker sessions. So when Sparkla sets up a Docker session, we have a client in the browser that is talking through to R or Python over on the right-hand side in different ways over various transport layers. And so we've got these nested boxes just describing how everything connects up to each other. So when you execute a code chunk in the browser, it's sending a connection via WebSockets to the Sparkla manager, which is then starting up a Docker session, which is a Docker container that has the Executa server in it. And that in turn spawns up executors in different languages that talks over standard input-output streams. So as I said before, these are really fast, but it's essentially just passing on, delegating that original request from the browser all the way through using those different transport layers. So that's what it looks like when you're talking to a session using Docker. But we've also set up Sparkla to use Firecracker. And Firecracker is a project from Amazon that was released about a year ago. And what Firecracker offers is both fast startup times, but also isolated environments with very strong security based on hardware virtualization. So it's using something in the Linux kernel called kernel virtual machines, and essentially starts up micro virtual machines for you. It does that really fast, and the advantage over Docker is that it's a lot more secure. So recently there have been vulnerabilities exposed in Docker which potentially allow for malicious code to be run to get out of a container, and Firecracker goes a long way to getting around some of those vulnerabilities. So we've been interested in, as well as supporting Docker, supporting Firecracker. So this diagram is virtually identical to the one before that I showed you with Docker, with the client and the browser talking through to the executors in the different languages. But this time we've got a Firecracker session, this micro VM that's running, and we're talking to it using VSOC, which is the mechanism for communication when using Firecracker. Again, that's a lot more secure than using something like TCP or HTTP. So that just shows the adaptability of the approach that we're taking, making use of different transport layers where they're most appropriate. So that's a brief overview of the different layers that we've been implementing with Executa and Sparkla. That's all a bit abstract, so I thought I would just show you a bit of a demo of how that actually works in reality. I'll just pause though, just to take any questions. Clarifications, Ben, do you think I need to clarify anything there?
I think that covers it. I mean, there's the good thing is that we have that consistent interface because we're using Sparkla. It's the same set of commands and so on to start containers or start processes and start executors and so on. We can switch out Docker or Firecracker, and hopefully performance and that should be pretty similar, but we get that safety of Firecracker. And of course, if something else comes along that we want to drop in there, we have the potential to do that.
Yeah, thanks. Okay, let me share my screen again. So let me close that, and I'm going to show you, hopefully you can see all that. Can you give me a thumbs up there?
That looks all right, yeah.
Okay. So on the right-hand side, we've got Sparkla running, and we've just got some logs that are getting shown to the console here. And one of the things that we've been working on is an admin page for Sparkla. So you can imagine having a Sparkla instance running. It would be on a virtual machine somewhere where you're providing sessions to users, and you might want to go through and check what sessions are running, and if necessary, stop sessions. So that's what the Sparkla admin interface is designed for, but it's actually also really useful for just debugging and just checking our code as we're developing Sparkla. So that's in that tab, and then in the other tab I've got a command that's listing all the Docker containers that are running on my machine, and it's updating that every 2 seconds. So you can see that's not changing. There are no Docker containers running on my machine right now, but I'm going to start some up now with the Sparkla admin. So how Sparkla and Executa, which is based on work, is that they have, we base everything around these nodes that are defined in the schema, and that extends to software sessions too. So we have a node type called a software session, and that has a number of properties that can be changed, and Sparkla will look at the requested software session and do its best to start up that session based on what you've requested. So you can see an example of a request that might be made from within an executable document for a new software session. In this case, it's got an environment which is called Stencila Sparkla Ubuntu MIDI, which is just a mid-size Docker image that we've created with a number of common packages in it. We're still building those packages out. At the moment, it's just got a few core R and Python packages in it. And it's got another set of properties around I'll just zoom this up a bit, around things like CPU usage and memory usage. And all of these have requests at the end of them because they're requests being made from the client, in this case the admin interface, for a new session. But each of those properties also has a corresponding limit property, which is set by the current user's permissions. Now, because we're using the admin interface, there are no restrictions there are no limits set, and so anything that we put in here will get reflected in the sessions that are showing up. So I'll begin a session now. You can see I've had another one that stopped recently, as well as a random ID. We're getting a random name for the sessions that we're just randomly generating, just make them slightly more human readable. So you can see I stopped the demonic stitch a little while ago, and the back fan has started up. So I can select that and have a look at that session that's actually started. So what gets reflected is we get the same software session node that I had in my requests with the properties that I requested, but now we've got an ID assigned and this random name assigned, the date that it started and its status. We've also got some other information, so the user that started that session and any existing clients. So this is my ID as an admin user, and I'm the one who started the session, and I'm also the only client currently. And I'll show you how that changes over time. So if I go to the terminal, we can see that we've now got a Docker session started, which is using that same image that is described in the software session node. So let me now try and execute some code in that. So that session is running, but what it's running is the Executa server within the container. So that's just sitting there waiting for requests, and it hasn't gotten anything yet. So let's start something up, and I'm just going to do some basic arithmetic here and press run, and you can see the run symbol goes for a little while, and then we get an answer back. Any subsequent requests will go a lot quicker, and that's just because what's had to happen in that first run is that the Python session within the container had to get started up. So there was a little bit of delay in starting up that Python session. So now inside that container, we have a Python session that's running, and we can start up language sessions in other languages too. We don't yet have R enabled, but let's do the same thing in JavaScript. So here we're running the same calculation in JavaScript, and that's a lot quicker to start up. And just to prove that it is JavaScript, let's do something JavaScripty and execute and get value for mathpy. If I change the language back to Python and run it, I get an error that math is not defined because it isn't in Python. So let's just stop that container now. So I'll go and end it. And we get a notification back from the server that it's stopping that session. And when we select it again to look at its details, we'll see that it's got a stop date. And so if we try to then execute the code, any code in that, you see we get a message within the code chunk that the session has ended. So what we've tried to do with Sparkla is make sure that we've got a lot of feedback to the user if something goes wrong. So both in terms of the session ending explicitly, like I just did when I stopped it, or for various other reasons. And I wanted to show you some of those other potential reasons next. So to do that, I'm going to go through these various properties that the software session has. And one of them is called clients request. So that's the maximum number of clients that is requested for a session. So you can imagine that for a software session, just to make sure that the session doesn't go completely overloaded, that we wouldn't want to have too many different clients making a request to it. And so we're likely to put a default limit on that. But let me just show you what that looks like using this request parameter. So let me say the default is currently there set at 10, but let's just say that we only want a maximum of 2 clients using this software session. And I'll start that up. So we now have a new software session down the bottom here called Venomous Goat. I can select on that and let's execute some Python code again. Let me try and do something a bit more interesting. And it's only slightly more interesting. I'm just going to create a random number. So there's my random number in that Python session. And let me also define a variable x. So there's a variable x defined in that session now. I can see it as x. Now, what I can do is start up a new client for that session. So this is a client interface that this might look like something that we might see within an executable document, where we've just got a code chunk. We don't have any special privileges or ability to start up or end a session in a customized way. But that's connected to the same session, so X should be available. And it's not, my demo is failing. Yeah, demo failed. Looks like I've got some problems in there. Let me try that again. Yeah, okay, took a little while to load from there. But so this is connecting to the same session as the other client and the admin interface was, and I can change the value of X again to something else, and everything gets reflected in the client. So let me see what X is again. All right, so we have potentially 2 clients, but right now we have 2 clients interacting with the same session. And this is for the use case where you might have a collaborative document that you're both editing, where you want to be able to, in real time, be able to edit the text, but also the code and look at the results. So we wanted to enable more than one client to be able to connect to the same software session. Let me go back now and create another client to Venomous Goat. So here's another client, and if I go and try and get X from in that client, it tells me that the maximum number of clients is already using the session. So I don't have any access to that session from this new client. What I'll do though is I'll stop my first client, and what that does is it disconnects that client from the client list. So I no longer have 3 clients attempting to connect to that session. And if we look at Venomous Goat, now I should just be back to 1 client, which is this admin interface, which is connected. And now in the second client, now I can connect to it and look at the value of X. And if we go back to the admin and select that, you'll see that we now have 2 clients, the admin and this new second client that I created. So there we have some real-time control of the number of clients connecting to sessions, and yeah, we think that will be really useful in places like Google Docs, where we want to put a limit on the number of clients, but also when users drop off that session, allow other users to enter and start using it. The other thing I wanted to show was just some of the timeout restrictions that we have. So we have properties called duration request and timeout request. Duration defines the maximum time that a session can run, and timeout is the amount of time before that session will time out due to inactivity. So if you haven't sent any requests to that session, say for an hour, in this case here, then it'll end automatically. And just like with the maximum number of clients, that we're getting feedback to the user on all of those things. So let me simulate that by having like only a 10-second timeout request on a new session. I'll begin that now. We've got this new session called Squalid Country. And you see a notification has already come up that the session will end due to inactivity. And we should see in a few more seconds, we should get a notification that that session is ending. There we go, because there hasn't been any activity over 10 seconds. Again, these notifications are not specific to this admin interface. They're notifications that will be sent to any client via that protocol that we've defined in Executa. So Squalid Country is now stopped, as you can see, because it timed out. We didn't make any requests to it. And if we select that, and we'll see that it's ended, and we've got a description of why it's ended. And we're storing that there so that if a client does come along and try and execute some code on it, then they get a reason for why that session has ended. And we could do the same thing for duration requests. So let's just give this a silly 10-second duration for this session. And we'll get the same notifications. The timeout and duration limits will be useful for just providing free sessions to users, so people that are anonymous or haven't registered, that we'll be giving them free sessions to use, but we obviously don't want to have people mining Bitcoin or doing other nefarious things on there, so we want to limit the amount of CPU and time of those sessions. We don't want them to be taking up resources unnecessarily. So we'll be limiting things like the duration of those sessions over the top of those that are requested here. And the other thing that we've got the CPU and memory limits. I can't easily demo those to you now, but the network transfer request is another thing that we've just added, which is working too. So we can essentially turn off any network access from within a container within the Docker supported containers anyway, which again is really useful if we're trying to provide free sessions. We don't want malicious stuff going on from within a container to any outside sites. Yeah, so all of those sessions bar one has stopped. So let me just go across to our listing of Docker containers. You can see that that one, Venomous Goat, is still up. Let me end that. All the other ones stopped. And yeah, we should see this stop in due course. There's a little bit of delay at the moment with stopping containers, which is something that we've got to look at. It's only about 10 seconds. So yeah. So that was a brief demo of where we're at with Sparkla. And as I was saying, all that is based on top of Executa and the protocols it defines there too. So it's, yeah, proving to be a good approach and something that has been good to work with.
Thanks, Nokome. And hi, everyone. Pleasure to be here, and thanks for joining. I guess unless anyone has anything to follow on, I will go over some of the kind of how we build the components that we saw Nokome using to demonstrate the code expression and the execution aspects, and kind of some of the motivations for why we chose some of the architectural decisions that we made. Okay, so let me share my screen. Well, okay. So one of the things that we were aiming to kind of solve with the system for building a design system and a component system was to make it easy to expand and applicable in various frameworks as well as multiple different platforms. So for us, the important thing was that the components that we built were usable by us, but that they would also be able to fit into any other platform, like Nokome mentioned, Google Docs or the Stencila hub that we are working, as well as any future platforms that we may choose to target. And we did look at some of the flavors of the season, or not flavors, but like the mainstream frameworks is the word that I was trying to think of, as like React and Vue, which has been used on the platform, I think, historically. But we decided against those because of some of the decision making that had gone into Thema, which is a project we have spoken about in the past. But to recap, is that we were trying to build CSS styles that were targeting HTML elements in as a semantic way as possible, to make it easily translatable and make it decoupled from any class names and any kind of markup that might exist on an HTML page, so that it was easily reusable across projects. And in line with that, we decided to use a project called Stencila.js, which allows us to build native web components, which are relatively not new, but they have relatively recently reached a more stable footing in terms of browser support and the capabilities and standardizations for the specification. And one of the motivations for this framework, at least one of the appealing aspects of it for us, was that we were able to design these components and distribute them in a way that would allow other people to integrate it into various different frameworks. So this, once we build our components, you can take them and you can use them in your Angular, React, Vue, Ember, or just native JavaScript apps. And this native JavaScript app is how we've been consuming it right now, so that we don't have a coupling in our projects for other frameworks besides Stencil. And so I want to kind of go over some of our experiences with using this framework, some of the difficulties and challenges that we faced, as well as kind of some of the things that at least I have found very appealing in my experience working with it. So to kind of dive into the good for now is that we have had a pretty, I would say, a smooth experience with integrating them into the various projects that we have built out. That would be the Stencila Open that I think we shared last month, so we can see how that looks on the page. So if we see, I think, if we open up a notebook, you will be able to see some of the components rendering in location on the hub web page, and they have been decoupled from the from any kind of logic. We didn't have to build out custom integrations or any kind of extra code to make use of the components. And what I mean by that is that the cells, if we inspect the element of what this looks like, we can see that to make use of the code chunk, all we had to do was add a custom HTML tag. And this allowed us to take the output of the HTML and enhance it in a progressive way that didn't that is still functional and contains information and can be consumed without having JavaScript enabled or for screen readers. And once the JavaScript gets loaded, we are able to add extra functionalities like executing code, making the text editable, and just a host of other kind of logic layer gets added to the HTML. So if I come back to our design system library and documentation, we can see that we were able to build out we were able to build out numerous components, and we're building them in an atomic design system way, where we have the low-level elements that then get combined into some molecules. Let me increase my font size so it's a bit clearer. So, for example, the button elements, especially the extra small button elements, can be combined inside an action menu, where we can see them here, and they compose in a functional way, where we don't have to worry about styles or the CSS having conflict due to the shadow DOM that is being used by the Stencil framework. And it allows us to build the components that can be kind of dropped into third-party websites that are self-contained entirely. So the logic for what happens when you hover over these ellipses, the CSS needed to render and animate the expansion and the collapsing of this action menu, they're all self-contained, and all a user would have to do is add a simple HTML element that is a Stencila action menu that contains Stencila buttons inside it. And then everything is taken care of by the components that we have authored. And I think others would also agree that the utilization or the usage of these components has been very smooth. The second aspect that I think that we found really appealing is that the documentation for these components is self-generated by the framework. So if I open up the little README here, which should be, well, I think here. What's happening? Okay. If we open up the README for the component for the button, we can see all the various properties that we can make use of while for this component, such as the button type, whether it's disabled, or what kind of icons we can place inside it, which is the icon here that we see. And this ability to have the documentation generated as we build and we develop the components means that we don't have to spend extra time to make sure that the documentation is up to date. If the component changes, the documentation gets regenerated with it, and it means that we have a bit more, what do you call it, a bit more trust and confidence to use the components and not have to worry about incompatibilities. And one other thing that I want to kind of demonstrate is how we are trying to make things as accessible when from the ground up. So accessibility for us, is important in terms of both that the developer who are using these components know how to make use of it and they're approachable and then they find value from it. But then also that when these components are put to use and released into the wild, that the readers or the consumers of this component will be able to interact with it no matter if their mouse doesn't work, or if they're vision impaired, or they're using a screen unit, or any other types of things. And we have these automated tests that we run as we build out the design system, the component library documentation in this storybook to let us know if we have any glaring warnings or errors, or if we have overlooked something. And while this isn't a foolproof method, I think it gives us a good solid foundation that we can then build upon and try to be a bit more responsible with how we are building the components. And the last thing for the components, this I think is the code chunk that Nokome was demonstrating. And if we open up the sidebar here, is that we can see how the dependency of the component plays out. So if you recall, I was saying that the components are built up on top of each other and that they are composed. We can see that this code chunk utilizes 3 other components. It uses the Stencila code error, uses the action menu up here, and the Stencila button, which are these things inside the action menu. So when we go to add new functionality, or if we go to try to modify something, we have a better mental like a mental image of what are the potential components that we might have to also update, or what we might break by accident. So we can then go and test those components again and make sure that everything still works smoothly. And what I wanted to show is if we focus in on the error component, we can see that this component has a few properties, which is has stack trace, and we know the type of this property, and these types correspond to the TypeScript types that we're using, and that I want to show how we're using this JSON schema that we are building, and how this ties back into the Stencila schema project. So the kinds, so this is the generated code, and this is coming from some of the options that we have available in the schema, as well as the stack trace, which is set by the component. So this is not the right one. We want to look at code chunk. So this I code chunk is the interface for the JSON schema that we have of the Stencila schema project. And this means that the components, when we're building it out, we have static typing guarantees that this component will correctly render a generated or an error object that corresponds to the Stencila schema error type, which means if we update the version of the Stencila schema, or if we or if a future version of that schema breaks compatibility or renames a property, this component will be able to detect it ahead of time, and will give us a warning during compilation that this that something might go wrong and we will not be able to render it. So this means that if we change one project, then we're able to notice it or become aware of it in another project and make the necessary changes. I think the last thing I wanted to kind of maybe touch upon is some of the kind of hurdles that we faced with working with a project like this, which is relatively young in terms of the 1.0 release, as well as the size of the community compared to React or even Vue, for example. And that is that while we have faced, we have gotten a lot of benefits from it, we have also suffered from some kind of consequences for choosing a smaller framework, like the lack of questions, the number of questions that are existing on Stack Overflow, and some of the documentation is still missing for some of the API methods. So as you can see, there are some methods that are still not documented. But I think overall the community has been very responsive, and they have a good Slack channel that we've been able to make use of to get answers when needed. And as I demonstrated, we've been able to integrate this project into other, we've been able to integrate the framework into other projects that we've been building out successfully. And it's addressing our initial needs for having documentation, for being able to adapt styles. So as I mentioned, we have we wanted to be able to integrate with different platforms, and for that, for us, that means aesthetically as well as following the design guidelines for other projects. So for our internal projects, we have the Stencila brand style, but with just swapping out a style sheet, we're able to then go and be a good citizen in another platform like Google Docs without having to change either the HTML markup, the logic, or any of the other kind of rendering code. And if anyone is curious, this project, the Stencila and Designa, is available on GitHub. And you can see the storybook style guides online by following this link. And if anyone has any questions about the framework, our experiences, or some of the ways we've been able to problem solve for the requirements that I mentioned, please join us on Zulip or ask us here, and we'll be more than happy to answer. I think that's all I have for now.
Thanks, Alex. I had a couple of questions around that. So around the rendering with when you're using Stencil.js and when you update a component, so the errors, for example, has been updated, what's the mechanism for that update? So I'm familiar with something like React, which has a one-way rendering flow. So you take the data and you have a function which essentially renders that. Is it similar in Stencil.js, or do you take a different approach there?
So it's a bit similar in that both Stencil.js and React, they have static properties that are unidirectional. Though if you are not using any of the frameworks to set these properties, then you have to kind of manually update the JavaScript. You have to use JavaScript to manually update the properties on the element. And what I mean by that is, say you have your error component and you receive a new error, this framework Stencil.js on its own doesn't provide any ways of updating the message. All it does is it exposes the native web component APIs that are provided by the browser. And to interact, to set any properties on the components, you have to use the JavaScript, just native web browser JavaScript, and say, query select my component, and any of the properties that are listed in the README of that component, or that the component accepts, you can use a dot notation to access that and update it. So that's kind of how you interact with the component.
So yeah, okay, that explains it. So you're not having to manually change the generated DOM, but rather you're setting the properties of.
That's correct. That's correct. Yeah.
Thanks. I don't have any other questions. All right. Well, we're just about at our time. I don't see any other questions. Anything more from you, Ben? No?
No, I think obviously in the past month we've sort of been working together on that Stencila and Executa, and I think you've given a good overview of it.
Great. All right. Well, yeah, we'll be back here next month. Thanks for joining us, and we'll see you then, hopefully. Bye.
Thank you.